All right, so now that we've checked our variables and made sure all the data looks good and makes sense, the next thing we'll do is we'll run our bivariate correlation. So first of all, you need to figure out what is it that you want to compare. What two variables do you want to determine whether they correlate or not? So let's just pick two at random here. And so obviously you wouldn't do this at random if you were doing a study. It would be based on the literature. But let's say we've looked at the literature and we've identified destination image and destination risk as two variables that we're interested in knowing whether they correlate. So remember, this doesn't mean that one caused the other. It doesn't mean that the more positive we perceive a destination, the less risk we experience, right? We're not saying that there's a relationship in that way, or there's not a regression. Instead, we're saying that they might correlate. Destination image and destination risk move in the same direction across the Likert scale responses. In other words, if people have low image score or Likert scale responses, they should also have low risk responses, and vice versa. So that's a positive correlation. We'll also look at negative inverse correlations as well. So let's choose our two variables. So here we're going to look at what is the correlation between destination image and destination risk. And when we convert that to a null and alternate hypothesis, we might say that there is a correlation. There is no correlation, the null hypothesis, there is no correlation between destination image and destination risk. And the alternate hypothesis, there is a correlation between image and risk. So here we go. We're going to click on Analyze. And before we run the correlation, it is a very useful step to first visualize the data. So by visualize the data, what I mean is if you're able to look at all of the Likert scale responses on a graph in circle form or dot form, can you identify any patterns in the relationship between our two variables? So let's try it with destination risk and destination image. So we're going to go to actually graphs. I want you to go down to legacy dialogues and choose a scatter dot graph. We're going to choose a simple scatter and click define. And here we're going to put our two variables in. So we're going to compare destination risk, so we can move that to the y-axis, with destination image, and we'll put that on the x-axis. And you can keep all other options the same. We'll hit OK, and let's take a look at the output. So here's the graph. So essentially this is showing where destination risk and destination image intersect. So for instance, this person here identified destination risk as a 3 point, whatever that is, 3.2. And they also identified destination image as around a 3.2. So that seems to correlate. However, what about destination risk for this person? 7. So strongly agree. Whereas for destination image, very moderately disagree. So that doesn't align. If you look here, what you want to find is a trend from the bottom left to the top right. And the closer these dots are to that line, the more likely that we see a correlation between the two. But again, we're not doing a regression yet. So right now we're just looking at the shape of these dots. From this, I would assume that there is a weak or very immoderate relationship, correlation. So in other words, these two variables do appear to be somewhat correlated, but not strongly. But we can't determine that from just looking at the graph. We need to actually run the analysis in SPSS. This is just a good first step. Okay, so what we're going to do is click on Analyze, Correlate, and this time we're going to choose Bivariate. So we're doing a bivariate correlation. So here we have our selections here. And we want to essentially look at the relationship between two variables. So our two variables are destination image and destination risk. Keep all of these options the same, And just make sure that your Pearson correlation coefficient box is checked. You're doing a two-tailed test of significance, and you're flagging significant correlations. That will just put a little asterisk beside the significant ones to make it easier to identify them. When you're ready, you'll hit OK. Here we have the correlations. You'll notice that destination image and destination image are positively correlated at 1. What does that mean? So actually, there's a handy table here that will show us what the significance are of these R values. So an R value is essentially how strong is the correlation between two variables. We call it the coefficient, the correlation coefficient. So a 1, either positive or negative, is what we call a perfect correlation. We don't see a lot of that in psychology, right? Something being perfectly correlated. There's always going to be subtle deviations from that. So it's very rare. A 0, on the other hand, is no correlation. They are not in any way associated with one another. And then we have a range from weak, moderate, to strong correlations, depending on the two variables that are being compared. So here we have destination image and destination risk, and they are correlated at 0.263. Remember, we're not taking this 1 here. This 1 is saying that destination image is perfectly correlated with destination image. That makes a lot of sense. It's the same variable. So that should be 1 there. You'll also notice that from this middle point of this table and down, the values are just repeated. 0.263, 0.263, 1, 1. Less than 0.001, less than 0.001, and 190, 190, right? And the reason is because we have image compared to risk here, and then risk compared to image here. So it's just repeating the same information. So you can just focus on the top half of this graph, or this table. Okay, so let's refer to our R values and figure out how strong the correlation between risk and image is. So they have a 0.263 correlation at a less than 0.001 significance level. So the correlation is significant. The two variables are correlated. The question now is, how correlated are they? And the answer is 0.263, not very much. They're kind of around the 2 here, right? So right in this point, they are weakly correlated. So they're statistically significant, the correlation, but the correlation itself is quite weak. All right, let's do one more example. So let's go back to analyze, correlate, bivariate, and this time let's bring in all of our variables. Remember, bivariate correlation will only look at the differences between two variables, but if you bring in all 5, it will run multiple analyses all at one time. So here we have image and image, 1, risk and risk, 1, experience and experience, 1, all the way on a diagonal. So if you see this diagonal of 1s, that's a good sign that you've done the analysis right. If we look across, we can compare image to all of the other variables. So let's say we want to know how does, let's go back to our original question. Remember, the DMO wants to know how do things like risk, experience, satisfaction, and revisit intention, these 3 things, image, risk, experience, and satisfaction, affect revisit intention. Well, we can't say definitively using a correlation that any of these impact on revisit intention, but we can say that they correlate, okay? So let's look at what correlates with revisit intention. We have destination image, 0.631, risk, 0.294, experience, 0.731, tourist satisfaction, 0.637. So of the 4 variables, destination experience appears to be the most correlated with revisit intention. This is not to say, again, I can't say this enough, not to say that experience impacts revisit intention. We can't do that with a correlation, but we can conclude that the 2 variables are related to one another. Okay, so we can do that because we have a significance of less than 0.001 and the R value of 0.731. And if we come back to our table, 0.731 is a strong correlation, and therefore we would conclude that we reject the null hypothesis if we were to compare experience and revisit intention. We reject the null hypothesis and say that there is a significant correlation between these two. However, going back to our early example of risk and image, you can say that we reject the null hypothesis. There is a significant correlation. However, the correlation is weak. Okay, so all of these have a significance level of less than 0.001. These are all significant correlations. However, the strength is just as important, if not more so, when doing that analysis.